this video is all about dilations. And dilations is a type of transformation that you can take a shape on a coordinate plane and you're either growing it or shrinking that shape down. I'm going to be using the word scale factor. That's a vocabulary word you should know, but it means that you're multiplying each one of the points. Remember, factor means to multiply. All right, so take a look at this example here, and ignore this red point here, but take a look at this example. The black represents the original shape, and here's my ordered pairs. And then the red represents the dilation. What do you notice is happening about that shape? If you look carefully at the coordinates, do you notice that each one of these coordinates is being multiplied by 2? Negative 1 times 2, 1 times 2, 1, 3. Do you see how each one of those factors is being multiplied by 2? The scale factor is 2. When that happens, each one of the ordered pairs grows, and therefore the shape is growing. Also, notice how far this shape, original shape, is from the origin. And now look at the dilation. Do you see how the dilation is twice as far from the origin? When the shape grows, it also gets farther away or closer to the origin. If a shape is shrinking, it's going to get closer to the origin. If it's growing, it's going to get farther away from the origin. Take a moment to write this down on one of your coordinate planes, copy this section into your spiral notebook, and then we'll continue on with the next couple where you're going to try some on your own. All right, let's call this example 2. All right, here we have our original shape. We're going to apply a scale factor of 3. So go ahead and pause the video, record your shape on the next coordinate plane on your note sheet that I gave you in class. And we're going to apply the scale factor of 3. So in your notebook, write down each of these ordered pairs, apply that scale factor, and see if you can figure out what the new ordered pairs will be, and then graph that shape on the coordinate plane. And take a look and see what's happened to it. Did it grow or did it shrink? All right, because we're using a scale factor of 3, we're multiplying each one of these coordinates by 3. So 1 times 3, 1 times 3, 4 times 3. Check your coordinate pairs. And now I'm going to go ahead and graph this, and we'll see what's happening to the shape. Can you already tell? Since we're doing a scale factor of 3, 3 being a whole number, the shape is growing. It's getting 3 times as big. I knew I was going to do that. Wrong marker. 3 times as big. All right, let's go ahead and graph and see. We've got 3 times 3. Again, I'm expecting you know how to graph at this point. 3, 12. I don't think I have enough room. 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to imagine it's going to be up here somewhere. 3, 12. And then we've got 12, 3, which will be somewhere out here. We connect these dots, and yours will be much more exact because you have a larger coordinate plane. Do you see how the shape grew? And it also got 3 times as far away from the origin. Here it's one little box away, 3 times as far. All right, let's try another one. Go ahead and pause the video, record your shape as well as your original ordered pairs. See if you can apply a scale factor of 1/3 this time. As you're recording the shape and the ordered pairs, kind of get an idea. What do you think is going to happen? Make a prediction, and then go ahead and work it out and see how you do. All right, since we're multiplying now by 1/3, you should know that when you times by a fraction, it's getting smaller, right? So we're doing negative 3 times 1/3, right? 0, of course, stays as 0. Anything times 0 is itself. And then times 0 is 0. Negative 9 times 1/3. Negative 6 times 1/3, and you could, of course, use a calculator if you need to. Hopefully you can do this in your head. So this time, your shape is getting 3 times smaller. 3 times smaller, or you could say 1/3 as big, right? Same thing. And it's getting 3 times closer to the origin this time. So let's go ahead and graph this. We've got -1, 1. For my visual folks, 0, -3. And we've got -3, -3, and -2, 1. See how we're closer to the origin? And our shape has now gotten smaller. If you're multiplying a scale factor of a fraction, it's going to get smaller. All right, we've got one more. Go ahead and pause the video, record your graph on the next coordinate plane there on your note sheet, and we're applying a scale factor of -2. What do you think is going to happen if you're multiplying by a negative scale factor? Go ahead and record your arrow notation in your spiral notebook. And let's see. Now we're multiplying by a -2. A -2. So we've got 4, -2, positive 10, -2, 4, -12. All right. Let's go ahead and graph this one. And then we can fill this part in. We've got 4, -2, 10, and 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. All right. So I'm not using a ruler, but you might be able to make this a little bit straighter. Okay. What seems to be happening with this shape? Here is our D, our A, and our B. What seems to be happening with a negative? We're still multiplying by a whole number, so do you see how it's gotten bigger? So it is twice as big. It's twice as big, but where are we from the origin? Not only are we twice as far away, but we're also a reflection. A reflection. Twice as far away, or actually I probably should say rotation. It's really a rotation all the way around. All right, so it's still 2 times away from the origin, but we also have a rotation involved here. So if your scale factor is a whole number, it's getting bigger, twice as far away from the origin. If the scale factor is a fraction, it's getting smaller and it's getting closer to the origin. And if you have a negative number, it is getting, if it's a negative whole number, it's still going to get big. If it's a negative fraction, it's going to get small. But in addition to the distance from the origin, we're also doing a rotation as well. All right, come on back to class and we will do some more practice problems together. See you soon.